In order to graph rational functions like this, you're going to type it in the calculator, and when you do that, you'll see a graph that looks like this. It should remind you of when we were graphing the inverse variation functions the other day. So the name of the shape is a hyperbola, like a parabola, but hyper instead. Hyperbola. And the line right here, right on the y-axis, that the hyperbola does not cross, and then the line right here on the x-axis that it does not cross, those lines are called asymptotes. So they're lines that a graph approaches but never touches. So it's not allowed to cross them, because if it did, look up in this equation right here. If x was 0, then the function would be undefined because you can't divide by 0. It would be an error in the calculator. So wherever a function is undefined, that's where an asymptote will be, because your graph can't be there. It can't cross there. In order to graph hyperbolas, I'm going to make us put a few things on the graphs. We're going to put where the zeros are, and we're going to put where the vertical asymptote is. Just the vertical. We're not going to deal with horizontal right now. And the zeros will be where the top equals 0. So you look at the top and you solve that for x. And then if you want to know where the vertical asymptote will be, where the graph cannot cross, you look at the bottom. And you look at that when you solve it for x, when you set it equal to 0. So let's look at this first one. The top is already factored, so we can immediately set those equal to 0 on the top, and when we do that, we'll get x equals -1, because that's a +1, and we'll get x equals +3, because that's a -3. So on the graph, I'm going to put a dot on -1 and at +3, because the graph will go through those 2 points. The next thing we'll figure out is what the vertical asymptote is. So we just look at the bottom. We'll set that equal to 0, and when we solve that, we get x equals +2. So through 2 on the x-axis, we have a vertical line. And the convention when you draw an asymptote is that it's a dotted line. So there's the asymptote. And now to get the shape of the hyperbola, you could make a table, but you'd have to plug in your x values into that equation right there. And it's a little bit faster just to type it in and then sketch the graph as you see it on the calculator. So what I'm looking for is that your graph goes through the 0 and then it does not cross the asymptote. It can approach it, it's just not going to cross it. So same thing over here. This one starts out close to the asymptote and then it kind of bends away. So that's a rough sketch of what you would see on the calculator, and I would accept this graph because I have my zeros clearly identified, I have my asymptote, and I have my graph not crossing that asymptote. So that would be an acceptable graph. Now on B, when you want to find the zeros, you need to figure out what x is by factoring that top first. So we're going to break it into 2 sets of parentheses, the 2 factors, with x and x, and we need to find the factors of 8 that add up to get 6. So the factors of 8 that add up to 6 will be 2 and 4. So I'll put +2 +4. On the bottom, I'm just going to recopy the x minus 5. Now we can identify what the zeros are. We just look at the top, and since we had +2, one of our zeros will be at -2, and the other 0 will be at -4. So you flip the sign to get the zeros. So I'm going to go ahead and plot those. -2 and -4. And now we need to look to see where the vertical asymptote is. And we look right here. When we solve that for x, it will be +5. So through x equals +5, I'm making my vertical dashed line. Sometimes your asymptote's between the 2 zeros, like on the example we did before this. Sometimes it's on one side or the other. When that happens and you type your function in the calculator, Oh, when you type it in, by the way, this is super important. If you're wondering how I got that graph in A, you have to put parentheses around the entire top and the entire bottom. So when you go to type the functions in, see how there's already parentheses here and here? You have to put another set. So right there and right there on the outside of that one. I just covered the other one up. So there'd be 2. And then also around the bottom. So over here, when you type it in the calculator, you would type parenthesis, parenthesis, and then another one out there, and then you also have to put the bottom in parentheses. You can type either the factored form or the original in the calculator. So you would type that with parentheses around it, the divide button, and then you would type that. Okay, so that's how it shows up in the calculator. When you type it in like that, for this function, you see something that comes up, and then it sort of looks like it touches the x-axis, but it actually comes slightly above the x-axis and goes back down through those 2 dots, sort of like that. And if you're on zoom 6, that's all you see. So what you need to do is zoom out for this problem. Sometimes you can see both parts. But for this one, you need to zoom out, and when it does that, you'll see the rest of the graph on the other side. Make sure you get both parts of the hyperbola. Most of the time when you graph a rational function, your shape will be a hyperbola. But sometimes you get something that's not shaped like a hyperbola. You're going to get a straight line. And if you have a straight line, so not that crazy kind of boomerang shape like that, it's going to be a straight line. What straight lines do is they go right through asymptotes. They don't even care that they're supposed to approach them and not touch them. Straight lines just go right through them. So what we do is we allow that to happen, but we put a hole where the asymptote is. So this is how you know if you're going to have a hole in your graph for your straight line. It's if you have the same factor on the top and the bottom. Then there will be a hole where you solve for x. So let's just look at this first example. We have this factor, x minus 2, this factor, x plus 2, and that factor, x plus 2 on the bottom. So what's going to happen, because we have this x plus 2 on top and that x plus 2 on the bottom, is normally if we saw that x plus 2 on the bottom, we'd have a vertical asymptote there. Our hole is going to be at x equals negative 2. So usually we would think about that being a vertical asymptote like that right there. But I'll show you what's going to happen. Let's go ahead and simplify this by canceling those out, and we're going to graph what's left. So this is the part that's left, and that's what we're going to graph. We're going to graph f of x equals x minus 2. Don't flip that sign, just recopy what you have left. So I'm going to go to the y-axis, I'm going to go down 2. Now I'm going to count the slope. In front of the x there's a 1 over 1, so I'm going to go up 1 and over 1 from that. And I'm going to keep plotting some dots and then connect them with a line. So that line just went right through that asymptote. So what we're going to do is go to where it crosses the asymptote, which is right here. And instead of letting it cross there, we're going to put a circle there to show that it's not supposed to be at that point because that's where the function is undefined. The next example, we're going to start the same way we started the second example in example 1. So first, we have to factor the top. So we write the 2 factors, and we need to find the factors of 6 that subtract to get 1. So the factors of 6 that subtract to get 1 would be 3 and negative 2. So that's what we have on top. And on bottom, we have x minus 2. So now we see, oh look, we have the same factor on top and bottom. There will be a hole at x equals positive 2. We solved the bottom for x. That's where the hole will be. And now we simplify and graph. So we're going to cross those two factors out and graph what's left, which is f of x equals x plus 3. So that's what we're going to graph. F of x equals x plus 3. So we need to go to the graph, start up 3. We need to count the slope up 1 over 1, just like this. And if you're used to drawing the vertical asymptote, that's fine. We can do that at 2. And so what we do is where our line crosses that asymptote, we just put a little hole there instead because it's really not supposed to be there. Oops, I meant to erase. So we'll erase that and put the hole right there.